Bismillahirrahmanirrahim. I'd like to share with you today one of my favorite interactions with my students. In this part of the course, what I like to do sometimes is take 3 pencils like this, or pens and pencils of different sizes, and I like to give it to the students. And I tell the student in front of me, okay, take this, okay? Make a triangle out of these 3. And then they take it, and then, try and they see what, they can't do it. And I said, give it to somebody else. And then they take it, and then they try to make a triangle out of these 3. And then they see they can't do it. And then I tell them, see, you just can't make a triangle out of any 3 sticks of things. If you had 3 sticks, you just can't assume that they're going to make a triangle, that you're going to be able to make a triangle out of it. And they're puzzled. And then I say, okay, well, look, what if I give you 3 sticks, okay? Like this. Here's 1 stick. And then I give you 2 other sticks. Okay, here's 1. And here's another one. Well, how are you going to make a triangle out of that? You can't, right? Because they're too small. So it becomes apparent to them, then they realize it's true. You just can't make triangles out of just any 3 sticks. And then I say, okay, well, what are the requirements of these 3 sticks? When can 3 sticks make a triangle? And when can't 3 sticks make a triangle? So let's think about it for a second, okay? Let's say I give you this 1 big stick. Well, let's give it a number here. Let's say this is like 10 centimeters or something, right? And then let's see if I give you 2 other sticks, okay? This one is like, I don't know, 1 centimeter, and this one is like 2 centimeters. Are they going to make a triangle? You say no, right? Because it's too small. Okay, what if I make them like this? Okay, here's one that is like 3, and here's one that's like 3. Can they make a triangle? No, because it's like 6, right? They're gonna fall, and you're not gonna be able to make a triangle out of it, right? Okay, so how about this? If I give you one that's like, I don't know, 5, all right, and how about one that's like 4? Can they make a triangle? Oh, getting closer though, right? I don't think so. You still can't make a triangle out of these. Well, how about this? How about if I give you one that is like 5 and another one that's like 5? Right? Well, it's supposed to be 5. Unless this one is 5. So, well, are they going to make a triangle? No, because they're equal lengths, right? They're going to fall right on top of each other, right? So, no, not even that. How about this? How about this one is 5 and this one is like 6? Can you make a triangle? Then you say, oh yeah, right? Now you can make a triangle. So one observation that we made is that you just can't take any 3 sticks and make a triangle out of it. And the second is that we're trying to explore some principles to determine what are the requirements of the 3 sticks or 3 sides of the triangle that are going to be able to make a triangle, right? Okay. That is the triangle inequality theorem. The triangle inequality theorem states that the sum of any 2 sides of a triangle must be bigger than the 3rd side. In other words, here AB, the measure of AB like this, plus BC must be greater than AC. It has to be. That's the only way. So if this is 10 and this is 5, it has to be at least bigger than 5, like 6 or something like that. Okay? The sum of any 2 sides of a triangle must be bigger than the 3rd side. So that applies to any 2 sides. In other words, this side plus this side must be bigger than, when they are added together, than this 3rd side. And if you take this side and this side, when you add them together, they must be bigger than the 3rd side. So the triangle inequality theorem states that the sum of any 2 sides of a triangle, that the sum of any 2 sides of a triangle must be greater than the 3rd side. Okay? Now let's say if I have a triangle over here. This side is 10 and this side is 5. Now let's try to figure out, what does this side have to be x for this to make a triangle, right? What does x have to be? Can x be 2? No. Can x be 3? No. It's not big enough, right? But what we do know is that 5 plus x has to be greater than 10. This plus this, it must be greater than 10. Correct? Okay, so then we can solve for x. So, you can subtract 5 from both sides like this, right? And then you get x is greater than 5. So there we have it. Now we know that x must be greater than 5. All right, so x could be 6, right? Yes. Can x be 7? Yes. Can x be 8? Yes, right? Can x be 8? Right? Okay. Now, how about this? Can x be like 500? Can x be 500? No, then it would be, if x is 500, it's kind of like this, okay? Then you have x is 500, then you have like 5 over here, and you have 10 over here. That's not going to work either, right? So x cannot be like a huge, gigantic number. So x has to be greater than 5, you realize, but then it has to be some other restriction, right? The other restriction is going to be this, that the sum of any two sides of a triangle, we said this plus this must be bigger than this, but then we also have to realize that when you add this plus this, they must add up to be bigger than x. So the second inequality is that 5 plus 10 must be greater than x. 5 plus 10 is 15, must be greater than x. You can rewrite this as x is less than 15, right? You just have to make sure that the mouth of this sign is facing the 15. Here's the mouth of this sign facing this 15. So now we have it. See, x has to be bigger than 5 and x has to be less than 15. As long as x is bigger than 5 and x is less than 15, you can make a triangle out of this. So this is the triangle inequality theorem. It is great fun, and it states the sum of any two sides of a triangle must be greater than the third side. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.